Ant architecture. Here you can see an architecture block diagram of Ant. Apache Ant is a software tool for automating software build process, which originated from the Apache Tomcat project in early 2000 as a replacement for the Make build tool for Unix. It is similar to Make, but it is implemented using the Java language and requires the Java platform. Unlike Make, which uses the Makefile format and uses XML to describe the code build process and its dependencies. Here, source code of a software application consists of a collection of connected components organized into subsystems, which are in turn grouped into levels and layers. To explore the features and effects of systems architecture, we need to understand this arrangement more specifically. It will clarify our discussion to refer to an example. Here we are referring one of the software applications. Here the architecture of 1.3 of Ant, and I'm referring other versions through this architecture in the moment. Traditionally, designers have represented the architecture of their source codes with a block diagram, such as this figure, which depicts the system's decomposition into subsystems. We define subsystem as a set of components and or other systems where presence of a block inside another represent a parent to child relationship in the decomposition. For example, at first level of decomposition, Ant version 1.3 consists of 4 subsystems. Taskdefs in turn breaks down into 2 lower level subsystems, as does in the for example, at the first level of decomposition, Ant version 1.3 consists of 4 subsystems. Taskdefs, types, Util, and asterisk, where asterisk stand for a group of miscellaneous components. The subsystem Taskdefs in turn breaks down into 2 lower level subsystems, as does in the subsystem Util. Each of the subsystems shown in this figure is ultimately a collection of components which are not shown individually. Thus, z-axis of the figure coming out of the page are related to the level or depth of the decomposition. For example, the first level is formed by the 4 subsystems immediately below the root node, level 0. And the architecture has 2 levels because of the subsystems in the first level. Taskdefs and Util contains other subsystems. Compilers and Regexp. Z-axis is going like this. The vertical layout here, y-axis of the subsystems and components of the block diagram shown in this figure is also meaningful. Subsystems and components located at the bottom of the diagrams are intended to serve the subsystems above. These layers are defined by the system's architect's design rules. Software is often architected in layers to provide coherent command and control structure, such as components in higher layers can call depends on components in lower layers. The opposite situation where lower layer components depend on higher layer once is possible but undesirable for reasons we will for some reasons. Thus, the block diagram conveys information about both the levels of decomposition, which are related to the physical structure of the code, and the layers of intended dependencies which relate to the process structure of the code. Note that where one chooses to end the decomposition and declare the lowest level is the modeler's choice. In our analysis, we stop at the class level, although we could go down further to the level of methods and data members, and eventually even to lines of code. First, classes tend to provide a set of common functionality. For example, a set of low-level mathematical functions that is maintained as one cohesive piece of software, often in a single source file by a single author. Second, the main attributes of the architecture become apparent by the class level, so further decomposition would only obscure these insights. Third, this level of decomposition is consistent with the previous work focused on representing software architectures. Thus, for the purpose of our analysis, we treat each Java class as atomic component of the software architecture here. Here Taskdefs, types, utils, and other are inside Ant, and other and compilers are inside Taskdefs. Types and utils are below Taskdef, and other and Regexps are inside Util, and other miscellaneous things are below types and util. Here you can see a reference architecture for Ant. Ant is primarily used for building and deploying Java projects under Apache Software Foundation, but can be used for every possible repetitive task such as unit testing, execution, or documentation generation. As a build automation tool, it typically runs without a graphical user interface, receiving parameters directly from the command line. This characteristic allows it to be easily integrated into different continuous integration environments. So many open source and industrial projects have adopted Ant around the world, creating the need to continuously evolve the software and fix the defects found by the users. 24 versions of Ant were released since its inception in July 2000 to March 2013, including 9 major and 15 minor versions. All versions were implemented in Java. The first version 1.1.0, had 102 classes distributed into 4 packages. The software grew over the last years as a large number of task definitions were added. The last version available in the period of by March 2013 is version 1.9.0. is over 1,100 classes organized in 60 packages. This figure shows Apache Ant design time architecture with its major packages and allowed dependencies among them. The architecture has three major components: an utilities library, Util, an automation and notification framework, and a set of task definitions, Taskdefs. The utilities library provides a set of general use services which may be useful for several build automation tasks. The task definitions package contains several independent task definitions, each representing a build automation step. Finally, the central package represents a scheduler which reads a XML file stating the proper sequence of tasks to be executed during a build and coordinates their execution, notifying selected users by email when certain events happen during their execution. Task definitions may use the utilities library and the framework to perform their tasks. While the framework may use libraries for notification and task execution. And Taskdefs are connected to Util, and Taskdefs are connected to Ant, and Ant is connected to Util. Here you can see Ant version 1.1 in Apache Ant's architecture. This figure shows the package structure of Ant version 1.1. It is simple beast. The diagram portrays a structure whose clarity belies its capability. Even this youthful Ant boasted some powerful features. Concerns surface when we note that the configuration efficiency rests at 20% and will remain so throughout the history here, indicating that some packages might be too large, but we for the moment may not this worry and move on. Here Ant is connected to as Ant interacts with Taskdefs. Taskdefs interact with tar. You can see the servlets also. Here you can see Ant version 1.2 in Ant Apache's Ant architecture. The version 1.2 has its glad rags on and is ready to partly. An enthusiasm for utter transformation typifies Ant's early career. The number of packages saw from 14 to 13, veiling a rise in the number of classes from 800 to 1500. Most notable, however, is the configuration of these newly arrived packages splayed out, seemingly not in the service of the main Ant Taskdefs and types packages, but feeding off them. In the same in that these main three packages seem to provide services to most others. This, like version 1.1, would appear to be fine, to be a fine flexible structure. Here Taskdefs here the Taskdefs interact with Ant types, VSS, Java, CC, JLink, EJB, optional, JSP, meta and perforce and tar and mail. Ant interacts with Taskdefs, types, VSS, JavaCC, JLinks, EJB, optional, JSP, meta, perforce, perforce. Here types interacts with Taskdefs and VSS, JavaCC, JLink, EJB, optional, JSP, meta. Here you can see the Ant version 1.3 in Apache Ant's architecture. Another head-to-toe wardrobe change sees Ant go all vertical. The wave of packages that invaded version 1.2 have been repelled, and in their place compilers and Util help cement a pretty crystalline structure. Some mutually dependent bows have appeared, but they do not spoil the easy with which dependencies might trace themselves as packages undergo updates. Inter-package coupling therefore not being a concern. This structure enjoys promising prospects. Here you can see Taskdefs interacts with compilers, types, and Util, mail, and tar, and interacts with Taskdefs, types, compilers, Util, and Regexp. Here types interacts with Taskdefs and compilers and Util. Compilers interacts with Taskdef and types. Util interacts with Taskdefs and Regexp and types. Here you can see Ant version 1.4 in Apache Ant's architecture. The version 1.4 sees Taskdefs level up as it sprouts mail, RMIC, zip, and condition with optional and listener becoming system's new entry points and bringing the number of packages from 8 to from 8 in version 1.3 to 13. Still the diagram look coherent and well structured. Here listener is connected. Listener interacts with Ant, and here Taskdefs interacts with Ant, Util, types, armic, compile, optional, mail, tar, zip, and condition. Here Ant interacts with Taskdefs, listener, Util, types, RMIC, condition, and compile. Here Util interacts with Taskdefs and types RMIC and Regexp, Regexp, and types interacts with Taskdefs and Util RMIC compile and Regexp. Here you can see Ant version 1.5 in Apache's Ant architecture. The version 1.5, a massive upgrade, brings 1,000 new functions in its wake, and the results structurally are disastrous. The heritage remains clear. We can easily identify the figure here of the fundamental relationships established in version 1.4, but how the dependencies have thickened and grown. The great stiffening has taken place, where ripple effect were traceable in version 1.4. Version 1.5 brings disheartening waywardness. This is unfortunate too, because the structure might otherwise be sound, and if those main red packages graced what we presume to be the service providing classes arrayed below, this structure would be fine. All those curving lines however imply that almost as many dependencies go up as down, opening the door for opening door to a gang of murderous cyclic dependencies. Here you can see a Taskdefs interacts with the Ant, Util, types, CVSlib, filters, condition, zip, util, and tar, etc. And here you can see Ant interacts with typedefs, listener, types, CVSlib, util, and etc. Here you can see types interacts with the Taskdefs and util, CVSlib, util, zip, etc. Here you can see listener interacts with Ant and mail. And here you can see filters interacts with types, Taskdefs, util, and here util and Regexp. Here you can see Ant version 1.6.3 in Apache Ant's architecture. Version 1.6 adds another 1,000 functions, but it hardly matters. Ossified the main three packages, Ant, Taskdefs, and types lie embedded in dependencies offering no clear relations with other surrounds. Here you can see Taskdefs and types, selectors, util, and here the util, and here resolver, listener, CVSlib, mappers, modifiers, Regexp, zip, tar, etc. Here you can see Ant version 1.7.0 released in December 2006 in Apache Ant Architecture. The points represents here packages, and lines represent use dependencies between two packages. A package A depends on package B if at least one class from A depends on at least one class from B to implement its features. Due to space limitations, dependency directions and package names are suppressed. Instead of providing detailed description of the project architecture, the chart intend to show how complexity was incorporated into an originally simple software as it evolved. Here you can see 0 here interacts with 24, 22, etc. Here 1 interacts with 0, and here 2 interacts with 24, and here 22, etc. Here you can see Ant version 1.8.0 released in February 2010 in Apache Ant's architecture. Here the points represent packages, and lines represent use of dependencies between two packages. Here you can see Ant version 1.9.0 released in March 2013 in Apache Ant's architecture. Here points represent packages, and lines represent use of dependencies between two packages. Here you can see the directory structure. Here you can see the sample directory structure of a project while running test with Ant. From the perspective of build scripts, we are not interested in what our Java classes can do here. We only care about the code compiling as being able to run all automated tests as part of our build, getting a nice report out of the test run, which we can browse for details on test failures and so forth. The project's directory structure dictate a lot of what our build scripts need to do. Consider the relatively simple directory structure depicted in here. Our source code is split into two directories, src/main and src/test. Having separate source trees provides for an easier distinction between test code and production code, and also because makes writing build scripts a lot easier. Everything under X is about X, everything under Y is about Y. We also have similar split for compiled classes, compiled class files. Compiled production compiled production code goes to bin/classes main, and compiled test code goes to bin/classes test. Not surprisingly, the libraries we depend on are separated under lib/main and lib/test. Once again, the separation makes it easier to manage the different sets of dependencies for runtime and development, and simplified the act of creating deployment archive, which should only contain compiled production code and only runtime dependencies. In this project is basically here as an example. The Ant build script is located in the root of the project. Located in the root of the project directory. And speaking of the build script, we are ready to, this is the build script. Here you can see the project directory, and under that here src, this is the under src, this is the production code under src/main, and this is the these are the production goes here. Under src, you can see the test code under src/test. Here is test code. Here compile code follows the similar separation, like here, bin/classes main and bin/classes test. Here dependency is separated for production and test code here in this project here, and this is the build script in the root of the project directory. Now we are focusing on Taskdefs. Here we also consider tasks. Taskdefs add the task definition to the current project such that this new task can be used in the current project. This task is a form of typedef with the attributes adapter and adapt2 set to the values org.apache.tools.ant.taskadapter and org.apache.tools.ant.task respectively. Now we are considering the life cycle of a task. The method executing the task here, and the setter for the main message attribute. Here the step 1, the XML element that contains the tag corresponding to the task get converted to an unknown element at pass time. This unknown element gets placed in a list within a target object or recursively within another unknown element. The step 2, when the target is executed, each unknown element is invoked using the perform method. This instantiates the task. This means that task only gets instantiated at runtime. Step 3, the task get references to its project and location inside the build file via its inherited project and location variables. if step 4, if the user specified an ID attribute to this task, the project registers a reference to this newly created task at runtime. Step 5, the task gets a reference to the target it belongs to via its inherited target variable. Step 6, init method is called at runtime. Step 7, all child elements of the XML element corresponding to this task are created via this element's create xxx method, or instantiated and added to this task via its add xxx methods at runtime. Child elements corresponding to add configured xxx are created then at this point, but the actual add configured method is not called. Step 8, all attributes of this task get set via its corresponding set xxx methods at runtime. Step 9, the content character data sections inside the XML element corresponding to this task is added to the task via its add text method at runtime. Step 10, all attributes of child elements get set via its set via their corresponding set xxx methods at runtime. If child element step 11, if child elements of the XML element corresponding to this task have been created for add configured xxx methods, those methods get invoked now. Step 12, the execute method is called at runtime. If target 1 and target 2 both depends on target 3, then running and target 1 target 2 will run all tasks in target 3 twice. We can consider this example here. Make a task called my Java doc available to Apache Ant. The class com.mydomain.java.task implements the task here. As an example 2, we can consider package org.apache.tools.ant.taskdefs. Here you can consider we can consider task as an example 3, we can consider Taskdef here. Add a task definition to the current project such that this new task can be used in the current project. We can, as an error example, we can consider this Taskdef class dec 10 2012 my ant task cannot be found using the class loader and class loader. One problem here is that the ant class loader needs to know where the .class file sits. Here we are now we are considering other miscellaneous components. Here you can see some other tasks, and there are archive tasks including G unship, B unship 2 / unxz, G zip / bship 2 / xz, cab, EAR, JAR, JLink, manifest, RPM, sign, ja, ta, anja, anta, anwa, unzip, wa, and zip. And there's audit and coverage task, JDepend, and there are compile tasks, which we will consider it later. This includes depend, javac, jspc, net, rexxc, rmic, wljspc, as a deployment task, server deploy, documentation task, javadoc, ejb task, and execution task, ant and call, apply /exec on, depend set, exec, java, parallel, sql, sleep, subant, wait for. And there are file tasks, attrib, checksum, chgroup, chmod, chown, concat, copy dir, copy file, delete, deltree, filter, fix, clrf, get, mkdir, move, patch, rename extensions, replace regexpression, set permissions, sync, temp file, and touch. There are Java extension tasks, jalib available, jalib display, jalib manifest, jalib -resolve, and there are logging tasks, record. There are mail tasks, mail, my mail. There are miscellaneous tasks including default, exclude, echo, fail, gen key, hostinfo, input, script, sound, splash, sql, taskdef, tstamp, typedef, xml, validate. And here these log tasks include record, logging task, and there are preprocess tasks, antlr, structure, import, include, java cc, java h, jjdoc, jjtree, macrodef, native to ASCII, preset def, translate, slt. There are property tasks available, base name, build number, condition, dir name, echo properties, load file, load properties, make url, path convert, property file, up to date, which resource, xml property. And there are remote task, including FTP, REXEC, SCP, set proxy, SSH, exec, telnet. There are SCM tasks, CVS, CVS changelog, CVS pass, CVS tagdiff, clear case, continuous / synergy, Microsoft Visual Source Safe, PVCF, source offsite. There are testing tasks, JUnit and JUnit report. And here you can see a different way of looking at some tasks. Here you can see Java and EAR and JUnit and network related and FTP, source control logs and compiler and mail. As an example, we consider archive tasks. Here you can see an example of archive task jar. Here we want to create a multi-release jar file according to the specification GEP238. It defines on top of a jar the possibility to place additional or overwriting classes in a jar, which are available according to the Java version you run. Basically, this says that you have to set manifest entry multi-release true and place all additional or overwriting classes in meta -inf versions and number and package structure. Example meta -info /versions /9 org /Apache ant my class. In this example, we expect that the normal classes are compiled into java.classes and the Java 9 classes are compiled into Java 9.classes. Here you can see a special MF entry according to the specification, and here directory structure according to the spec, default classes loaded by old lesser versions of Java 9. And here pre-release classes require Java 9 plus for loadable via standard class loader. Here you can see jar. It sets its jar's set of files. Here dest file attributes it the jar file to create. Here this manifest, you can see manifest attribute, the manifest file to use. This can be either location of a manifest or the name of a jar added through a file set. If it's a name of an added jar, the task expect the manifest to be in the jar at meta-inf /manifest.mf. As an example too, we can consider this example. Here now we write a simple tasks. Hello world task, and then create a text file hello world.jar, in the src directory with this code, then we can compile and jar it with ant. Default target is jar, and via its depends attribute the compile is executed. But after creating the jar, we want to use our new task. Therefore, we need a new target use. Before we can use our new task, we have to declare it with Taskdefs. And for easier process, we change the default attribute. Here, the important is the class path attribute, and searches in its /lib directory for task, and our task isn't there, so we have to provide the right location. Now we can type in ant, and all must work here, and this is a sample code anyway, sample script here. You can see the output here after execution, and this is a segment of the script. Now we are considering tasks using properties, file sets, and path. So what to do? Handling three attributes: property, value, and print, and an execute method. Because this is only an introduction example, I don't do much checking. The class task, base class for all tasks, use project.createTask to create a new task instance rather than using this class directly for construction. This is in the package org.apache.tools.ant. With regarding the built environment, you can see the built file here. The other use.asterisk targets are deleted. Our first step is to set a property to a value and print the value of the property. So our scenario would be like this. Okay, it can be rewritten with core tasks. So what to do? Handling three attributes: property, value, print, and an execute method. Because this is only an introduction example, I don't do much checking. The property access is done via project instance. We get this instance via the public getProject method, which we inherit from tasks, more precisely from project component. Reading a property is done via getProperty name. Very simple, isn't it? This property returns a value as string or null if it is not set. Setting property is not really difficult, but there is more than one setter. You can use setProperty method which will do the job as expected. But there is a golden rule in Ant: properties are immutable, and this method sets the property to the specific value. Whether it has the value before that or not. So we can use another way, set new property. Actually, the set property method we are referring is something else, not this one. Now we are considering the set new property. Set new property set the property only if there is no property with that name. Otherwise, a message is logged. By the way, a short explanation of Ant's namespaces, not to be confused with XML namespaces. And Ant call creates a new space for property names. All properties from the caller are passed to the callee, but the callee can set their own properties without notice by the caller. There are some other setters too, but I haven't used them, so I can't say something to them, sorry. After putting our two-line example from here into the target names use.simple, we can call that from our test case. Setter for value and print. And this is same as this. And this Now we are considering Apache Ant EJB tasks and EJB jar in EJB tasks. Using this format, we'll create EJB jars. We'll create a EJB jar file for each variation of asterisk dash EJB dash dot EJB dash jar dot XML that is found in the deployment descriptor directory. The task EJB jar. This task is designed to support building of EJB jar files, EJB 1.1 and 2.0. Support is currently provided for vanilla EJB jar files, that is those containing only the user-generated class files and the standard deployment descriptor. Nested elements provide support for vendor-specific deployment tools. With regarding API, the class EJB jar extend the matching task class provided in the default Ant distribution to provide the directory scanning EJB jar file generator. This in the package org.apache.tools.and.taskdef.optional.ejb. In this example, shows EJB jar being used to generate deployment jars using WebLogic EJB container. This example requires the naming standard to be used for the deployment descriptors. Using this format, we'll create a EJB jar file for each variation of asterisk dash EJB dash jar.xml that is found in the deployment descriptor directory. Now we are considering Ant in execution tasks. There are different ways of using the tasks. The task Ant runs Apache Ant on a supplied build file. This can be used to build subprojects. This task must not be used outside of the target if it invokes the same build file it is part of. In API, class Ant built a subproject. This is in the package org.apache.tools.and.taskdefs. There are different ways of using the tasks. Now we are considering attrib in file tasks. Here make the run.bat file read-only and hidden. The task attrib changes the attributes of a file or all files inside the specified directory, specified directories. Right now it has effect only under Windows. Each of 4 possible permissions has its own attribute matching the argument for attributes commands. With regarding API, the class attrib equivalent for Win32 environments. Note, attrib parameters /s/d are not handled. This in the package org.apache.tools.and.taskdef.optional.windows. Now we are considering Jalip available in Java extension tasks. Here the search for the extension in a single file. The task jalip-available check whether an extension is present in a file set or an extension set. If the extension is present, then the property is set true. With regarding API, class Jalib available tasks check whether an extension is present in a file set or an extension set. This is in the package org.apache.tools.and.taskdef.optional.extension. Now we are considering record in logging tasks. The following build.xml snippet is an example of how to use recorder to record just the JavaC tasks. The task record. A recorder is a listener to the current build process that records the output to a file. With regarding API, the class recorder adds a listener to the current build process that records the output to a file. This is in the package org.apache.tools.and.taskdefs. Now we are considering mail in mail tasks. Here, send an email from me to you with the subject of results of nightly build and include the contents of the file build.log in the body of the message. The task mail, a task to send SMTP email. With regarding API, class mailer, base class for the various emailing implementation. This is in the package org.apache.tools.and.taskdefs.email. Now we are considering default excludes in miscellaneous tasks. Here print out the default excludes. The task default excludes alters the default excludes for all subsequent processing in the build and print out the current default exclude if desired. With regarding API, class default excludes alters the default excludes for the entire build. This is in the package org.apache.tools.and.taskdefs. Now we are considering NTLR in preprocessed tasks. Here invoke NTLR on a grammar file etc/java.g, writing the generated files to build/src. The task ANTLR invokes the ANTLR translator generator on a grammar file. with regarding API, class ANTLR invokes the ANTLR translator on a grammar file. This is the package org.apache.tools.ant.taskdef.optional. Now we are considering available in property tasks. Here sets the myClass.present property to the value true if the class org.whatever.myClass is found in the ant class path. Task available sets a property if a resource is available at runtime. This resource can be a file, a directory, a class in a class path, or a JVM system resource. With regarding API, the class available will set the given property if the requested resource is available at runtime. This task may also be used as a condition by the condition task. This is in the package org.apache.tools.ant.taskdefs. Now we are considering FTP in remote tasks. Here login to the ftp.apache.org as anonymous and upload all the files in the htdocs/manual directory to the default directory for that user. With regarding API, the task FTP, here the task FTP, the FTP task implements the basic FTP client that can send, receive, list, delete files, and create directories. With regarding API, class FTP tasks, basic FTP client performs the following actions: send file to a remote server. This is the default action. Get, retrieve files from a remote server. Del, delete files from remote server. List, create a file listing. chmod, change Unix file permissions. rmdir, remove directories if empty from a remote server. This is in the package org.apache.tools.ant.taskdef.optional.net. Here the getting files from an FTP server works pretty much the same way as sending them does. The only difference is that the nested file sets use remote directory remote dir attribute as the base directory for the files on the FTP server. The dir and the dir attribute as the local directory to put the files into. The file structure from the FTP site is preserved on the local machine. Here log into ftp.apache.org as anonymous and recursively download all .html files from the default directory for that user into the htdocs/manual directory on the local machine. Now we are focusing on CVS in CSM tasks. Check out the package /module ant from CVS repository pointed by the CVS root attribute, and store the files in here the $ open curly brace ws.dir close curly brace. Task CVS handles package /modules retrieved from the CVS repository. With regarding API, class CVS performs operation on CVS repository original 1.20 node. This implementation has been this implementation has been moved to abstract CVS tasks with the addition of some accessors for extensibility. This is in the package org.apache.tools.and.taskdefs. Here update the package /module that has been previously checked out into ws.dir here. Here silently -q create a file called patch.txt containing a unified -u diff which includes new files added via cvs add -n and can be used as input to patch. The equivalent using command line element is here. Or here. Now we are considering JUnit in testing tasks. Here no output will be generated unless test fails. The task JUnit, this task runs test from JUnit testing frameworks. The latest version of the framework can be found at https://junit.org. This task has been tested with JUnit 3.0 up to JUnit 3.8.2. It won't work with versions prior to JUnit 3.0. It also works with JUnit 4.x, including pure JUnit 4 test using only annotations and JUnit and no JUnit 4 test adapter. Class with regarding API, class JUnit task runs JUnit test. This is in the package org.apache.tools.and.taskdefs.optional.junit. Here they run the test defined in my.test.test case in the same VM. No output will be generated unless the test fails. With regarding we are considering JUnit.jar. We are now considering library dependencies. Here we are considering JUnit.jar. JUnit tasks may be in class path passed to task rather than Ant's class path. This is needed for JUnit tasks, and this is available at https://junit.org/. Now we are considering archive tasks. Tasks gunzip, bunzip, and xz. Expand resource expand a resource packed using gzip, bzip 2 or xz. Here the expand test.tar.gz to test.tar. Here the expand test.tar.bz2 to test.tar. Here expand test.tar.xz to test.tar. Here expand test.tar.gz to test2.tar. Here expand test.tar.gz to subdir / test.tar. Assuming subdir is a directory. Here download https://example.org/archive.tar.gz and expand it to archive.tar in the project base dir on the fly. Here the gunzip class in the API, the gunzip class gunzip expand the file that has been compressed with the gzip algorithm normally used to compress non-compressed archives such as tar files. This is in the package org.apache.tools.ant.taskdefs. Here the following is identical to this section. The same is also true for bunzip2 and bzip2 resource or unxz and xz resource. Copy offers additional features like filtering files on the fly, allowing a file to be mapped to multiple destinations, preserving the last modified time or configurable file system timestamp granularity. Now we are considering audit coverage tasks. JDepend. The class path in JDepend on audit coverage tasks. Class path is defined using a reference. The tasks JDepend invokes the JDepend parser. In the API class JDepend tasks. JDepend is a tool to generate design quality metrics for each Java package. It has been initially created by Mike Clark. JDepend can be found at https://github.com/clarkfare/JDepend. The current implementation spawned a new Java VM. This is in the package org.apache.tools.and.taskdefs.optional.jdepend. Here invoke JDepend on the build directory, writing the output on the standard output. Uh, the class path is defined using reference. Now we are considering Apache Ant server deploy in deployment tasks. This example shows the use of generic deploy element to deploy a component using a Java-based deployment tool. The task server deploy. The server deploy task is used to run a hot deployment tool for vendor specific J2EE server. The task requires nested elements which define the attributes of the vendor specific deployment tool being executed. Vendor specific deployment tools elements may enforce rules for which attributes are required depending on the tool. With regarding API, the class server deploy control hot deployment tool for J2EE servers. This class is used as a framework for the creation of vendor specific hot deployment tools. This is in the package org.apache.tools.and.taskdef.optional.j2ee. Now we are considering Javadoc or Javadoc 2 in documentation tasks. The task Javadoc or Javadoc 2 generates code documentations using Javadoc tool. Duplication, the Javadoc 2 task simply points to the Javadoc task and it's there for backward compatibility reasons. Since last task will be removed, since this task will be removed in future versions, you are strongly encouraged to use Javadoc instead. With regarding API, class Javadoc generates a Javadoc documentation for a collection of source code. This is in the package org.apache.tools.and.taskdefs. This is same as this one. Or this one. Now we are considering EJB jar in Apache Ant EJB task in EJB tasks. Using this format here, we'll create a EJB jar file for each variation of asterisk dash EJB dash jar.xml that is found in the deployment descriptor directory. The task EJB jar. This task is designed to support building EJB jar files, EJB 1.1 and 2.0. Support is currently provided for vanilla EJB jar files, that is those containing only the user generated class files and the standard deployment descriptor. Nested elements provide support for vendor specific deployment tools. These currently include Bolland Application Server 4.5, iPlanet Application Server 6.0, GBoss 2.1 and above, WebLogic 5.1, 6.0 session, entity beans using WebLogic.ejbc tool, IBM WebSphere 4.0, TopLink for WebLogic 2.5.1 enabled entity beans, JONS 2.4.x and 2.5 open source EJB server, Ironflare Orion Application Server 2.0. The task works as a directory scanning task and performs an action for each deployment descriptor found. As such, the includes and excludes should be set to ensure that all desired EJB descriptors are found. For each descriptor found, EJB jar will pass the deployment descriptor to determine necessary class files which implements the bean. These files are assembled along with the deployment descriptor into well-formed EJB jar file. Any support files which need to be included in the generated jar can be added with the support nested element. For each class found in the EJB jar, EJB jar will scan for any superclass or super interfaces. This will be added to the generated jar. This example shows EJB jar being used to generate deployment jars using WebLogic EJB container. This example requires the naming standard to be used for deployment descriptors. Using this format, we'll create EJB jar file for each variation of asterisk dash EJB dash jar.xml that is found in the deployment descriptor directory. With regarding API, the class EJB jar extend the matching task class provided in the default Ant distribution to provide a directory scanning EJB jar file generator. This is in the package org.apache.tools.ant.taskdefs.optional.ejb. Now we are considering Ant in execution tasks. These are different ways of using the tasks. Task Ant runs Apache Ant on a supplied build file. This can be used to build subprojects. This task must not be used outside of a target if it invokes the same build file it is part of. The class Ant built a subproject. This is in the package org.apache.tools.ant.taskdefs. Now we are considering attrib bin file tasks. Here make the run.bat file read only and hidden. The task attrib changes the attributes of a file or all files inside specific directories. Right now it has effect only under Windows. Each of the 4 possible permissions has its own attribute matching arguments for attrib commands. With regarding API, class attrib equivalent for Win32 environments. Note attrib parameters /s and /d are not handled. This in the package org.apache.tools.ant.taskdef.optional.windows. Now we are considering jalib-available in Java extension tasks. Here search for an extension in a single file. The task jalib-available check whether an extension is present in a file set or an extension set. If the extension is present, then a property is set. With regarding API, the class jalib-available tasks check whether an extension is present in a file set or an extension set. This is in the package org.apache.tools.ant.taskdef.optional.extension. Now we are considering a record in logging tasks. The following build.xml snippet is an example of how to use recorder to record just the Java-C tasks. The tasks record. A recorder is a listener to a current build process that records the output to a file. With regarding API, class recorder adds a listener to the current build process that records the output to a file. This is in the package org.apache.tools.ant.taskdefs. Now we are considering mail in mail tasks. Send an email from me to you with the subject of results of nightly build and include contents of the file build.log in the body of the message. Task mail, a task to send SMTP email. With regarding API, class mailer, base class for the various emailing implementations. This is in the package org.apache.tools.ant.taskdefs.email. Now we are considering default excludes in miscellaneous tasks. Print out the default excludes. The task default excludes, alter the default excludes for all subsequent processing in the build and print out the current default exclude if desired. Class default exclude, with regarding API, class default excludes, alter the default excludes for the entire build. This is in the package org.apache.tools.ant.taskdefs. Now we are considering ANTLR in preprocess tasks. Here invoke ANTLR on grammar file etc/java.g, writing the generated output, writing the generated files to build/src. The task ANTLR invokes the ANTLR translator generator on grammar file. With regarding API, the class ANTLR invokes the ANTLR translator generator on a grammar file. This is in the package org.apache.tools.ant.taskdef.optional. Now we are considering available in property tasks. here set the myClass.present property to the value true if the class org.whatever.myClass is found in the ant class path. Task available sets a property if a resource is available at runtime. This resource can be a file, a directory, a class in the class path, or a JVM system resource. With regarding API, class available will set the given property if the requested resource is available at runtime. This task may also be used as a condition by the condition task. This is the package org.apache.tools.ant.taskdefs. Now we are considering FTP in remote tasks. Here log into ftp.apache.org as anonymous and upload all files in the htdocs/manual directory to the default directory for that user. The task FTP, the FTP task implement basic FTP client that can send, receive, list, delete file, and create directories. With regarding API, class FTP tasks, basic FTP client performs the following actions: send file to a remote server. This is the default action. Get, retrieve files from a remote server. Del, delete files from a remote server. List, create a file listing. chmod, change Unix file permissions. rmdir, remove directories if empty from a remote server. This is the package org.apache.tools.ant.taskdefs.optional.net. Here you can consider getting files. Getting files from FTP server works pretty much the same way as sending them does. Only difference is that the nested file sets use remote dir attribute as the base directory for the files on the FTP server. And the dir attributes as the local directory to put the files into. The file structure from the FTP site is perceived on the local machine. Here log into the ftp.apache.org as anonymous and recursively download all .html files from the default directory for that user into the htdocs/manual directory on the local machine. Now we are considering CVS in CSM tasks. Here check out the package, package/module and from the CVS repository pointed out by the CVS root. Root attributes and store the files in here ws.dir. Here the task CVS handles packages/modules retrieved from the CVS repository. With regarding API, the class CVS performs operations on a CVS repository. Original 1.2 node. This implementation has been moved to abstract CVS tasks with the addition of some accessors for extensibility. This is in the package org.apache.tools.and.taskdefs. Here update the package /module that has previously been checked out into WSDIR. Here silently -q create a file called patch.txt containing unified -u diffs, which includes new files added via CVS add-n and can be used as output to can be used at input to patch. The equivalent using command line element is here. Or here. Here the task, here we are considering JUnit in testing task. Here no output will be generated unless the test fails. Task JUnit, this task runs test from the JUnit testing framework. The latest version of the framework can be found at https://junit.org. This task has been tested with JUnit 3.0 up to JUnit 3.8.2. It won't work with versions prior to JUnit 3.0. It also works with JUnit 4.x, including pure JUnit 4 test using only annotations and no JUnit 4 test adapter. With regarding here and with regarding API class JUnit task runs JUnit test, and this is in package org.apache.tools.and.taskdefs.optional.junit. Here runs the test defined in my.test case in the same VM. No output will be generated unless the test fails. Now we are considering JUnit.jar in library dependencies. This is needed for JUnit task, maybe on class paths passed to task rather than Ant's class path, and this is available at https://junit.org/. As an error example, we can consider this: unable to locate tools.jar, expected to find it in C:// program files /java /jar6 /lib/tools.jar. Build file build.xml does not exist. Build failed. Now we are focusing on compilers. These are compile tasks. As an example, we can consider this: compile all .java files under the implied directory by src here, and store the .class files in the implied directory by build here, and class path used includes xyz.jar, and compiling with debug information is on. The source level is 1.4, so you can use assert statements here. Here the javac compiler compiles a Java source tree. Here you can see src dir attribute, location of the Java files. Here you can see dest dir attribute, location to store the class files. Here you can see class path attribute, the class path to use. Here you can see debug attributes, indicates whether source should be compiled with debug information. If set to off, -g :none will be passed on the command line for compilers that support it. For other compilers, no command line argument will be used. If set to true, the value of the debug level attribute determines the command line argument. Here you can see source attribute, Java language features accepted by compiler as specified by -source command line switch. Valid feature versions are 1.3, 1.4, 1.5 or 5, etc. The attribute will be ignored by all implementation prior to Java C 1.4 or modern when Ant is not running in JVM 1.3, GCJ and JIX. If you use this attribute together with GCJ or JIX, you must make sure that your version supports this -source or -fsource for GCJ switch. As an example too, we can consider this. If you want to run a JavaC compiler of a different JDK, you should tell Ant where to find the compiler and which version of JDK you will be using, so it can choose the correct command line switches. The above in this example, it executes JDK 1.1 Java C in a new process and uses the correct command line switches even when Ant is running in a JVM of a different versions. Here you can see fork attribute, whether to execute Java C using JDK compiler externally. Here you can see executable attribute, complete path to the Java C executable to use in case of fork is yes. Since Ant 1.1, 1.6, this attribute can also be used to specify the path to to the executable when using JIX, JVC, JCJ or SJ. Here you can see compiler attribute, the compiler implementation to use. As an example 3, we can consider this. Here WL JSPC compiler, class to precompile JSPs using WebLogic JSP compiler, weblogic.jspc. This is tested only on WebLogic 4.5.1 and NT 4.0 and Solaris 7 and 8. Here you can see a source attribute, root of source tree for JSP, that is the document root for your WebLogic server. And here you can see dest attribute, root of destination directory, which you have set as working dir in the WebLogic properties. And here you can see package attribute, start package name under which your JSP would be compiled. Here you can see class path to use when compiling JSPs. Now we are focusing on depend in compile tasks. In this example, the depend tasks caches its dependency information in the dep cache directory. The task depend, a task to manage Java class file dependencies. With regarding API, the class depend generates a dependency file for a given set of classes. This is in the package org.apache.tools.ant.taskdef.optional.depend. Here remove any classes in the build.classes directory that depends on out of date classes. Classes are considered out of date with respect to the source. In the here the $ open curly brace java.dir close curly brace directory using the same mechanism as the Java C tasks. In this example, the depend task caches its dependency information in the dep cache directory. Now we are considering Java C. The source level is 1.4, so you can use assert statements. Task Java C compiles a Java source tree. With regarding API, class Java C compiles Java source files. This task can take following argument: source dir, dest dir, deprecation class path, boot class path, xdirs, optimize, debug, encoding, target, depend, verbose, fail on error, include Ant runtime, include Java runtime, source, compiler, release. Of these arguments, the source dir and dest dir are required. This is in the package org.apache.tools.ant.taskdefs. Here compile all .java files under the src directory and store the .class files in the here dest dir in the build directory. Open curly brace build close curly brace directory. The class path use indicate xyz.jar and compiling with debug information is on. The source level is 1.4, so you can use assert statements. Now we are considering JSPC. Here built all JSP files under /src/var into the destination /gen src in a package hierarchy beginning with com.i3sp.jsp. The task JSPC is deprecated. If you use this task with Tomcat's Jasper JSP compiler, you should seriously consider using the task shipping with Tomcat instead. This task is only tested against Tomcat 4.x. There are known problems with Tomcat 5.x that won't get fixed in Ant. Please use Tomcat's JSPC task instead. Instead of relying on container specific JSP compilers, we suggest deploying raw files *JSP and use the container built-in functions. After deploying, run a test suite, for example with Cactus or HTTP unit, against the deployed web application. So you will get the test result and compile JSPs. It asks basically Apache Ant task to run JSP compiler and turn JSP pages into Java source files. With regarding API, class JSPC turns a JSP runs a JSP compiler. This is in the package org.apache.tools.and.taskdef.optional.jsp. Now we are considering netrex C. Task netrex C compiles the netrex source tree within the running Apache Ant JVM. With regarding API, class netrex C compiles netrex source files. This task can take the following argument: binary, class path, comments, compile, console, crossref, decimal, dest, dir, diag, explicit, format, keep, logo, replace, save log, src dir, source dir, strict args, strict assign, strict case, strict import, symbols, time, trace, UTF-8, verbose, suppress method argument not used, suppress private property not used, suppress variable not used, suppressed exception not signaled, suppress deprecation, remove keep extension. Of these argument, the src dir argument is required. This is in the package org.apache.tools.and.taskdefs.optional. Now we are considering RMIC. Here runs the RMIC compiler for the class com.xyz.foobar. The compiled files will be stored in the directory $, open curly brace build close curly brace / classes / classes directory. The task RMIC runs the RMIC compiler for a certain class. With regarding API, the interface RMIC adapter, the interface that all RMIC adapters must adhere to. This is in the package org.apache.tools.and.taskdefs.rmic. Now we are considering WLJSPC. Task WLJSPC class to precompile JSPCs using WebLogic JSP compiler. WebLogic JSPC. With regarding API, the class WLJSPC precompiles JSPs using WebLogic's JSP compiler, WebLogic.jspc, tested only on WebLogic 4.5.1, NT 4.0 and Solaris 5.7 required attributes, src root of the source tree for JSP, that is the document root for your WebLogic server, dest, the root of the destination directory, what you have set as working dir in the WebLogic properties package, in the WebLogic properties package, start package name under which your JSP would be compiled, other attributes, class path, A class path should be set which contain WebLogic classes as well as application classes referenced by the JSP. The system class path is also append when the JSP C is called. So you may choose to put everything in the class path while calling Ant. However, since presumably the JSPs will reference classes being built by Ant, it would be better to explicitly add the class path in the task. The task checks timestamps on the JSPs and generated classes and compiles only those files that have changed. It follows the WebLogic naming convention of putting classes in _dir name / file name .class for dir name / file name .jsp limitation. It compiles the files through the classic compile only limitation, since it's is my this is in the package org.apache.tools.ant.taskdefs.optional.jsp. As an error example, we can consider this error, fail on error. This is an attribute which indicates whether compilation errors will fail the build in Java C task. Here, as an error example 2, we can consider this error occurred in Java C task. Compile failed. Build.xml 77 compile failed. See the compile error output for details at there are number of source files here. Types. Apache Ant provides a rich set of types. As an example, we can consider this one here, and here you can see the file set type. A file set is a group of files. These files can be found in a directory tree starting in a base directory and are maintained by patterns taken from number of pattern sets and selectors. Here you can see a dir attribute, the root of the directory tree of this file set, and case sensitive must include and exclude patterns be treated in a case sensitive way. Pattern sets can be specified as nested pattern set elements. In addition, file set holds an implicit pattern sets and supports nested include file, exclude file elements of pattern set directly, as well as pattern set attributes. As example 2, we are now considering class file set, type class file set. A class file set is a specialized type of file set which given set of root classes will include all of the classes class files upon which the root class depends. This is typically used to create a jar with all of the required classes for a particular application. With regarding API, you can consider class file set. A class file set is a file set that enlists all classes that depend on a certain set of root classes. Class file set extend file set its inherited properties, defining the domain searched for dependent classes. This is in the package org.apache.tools.and.types.optional.depend. This example create a file set containing all the class files upon which org.apache.tools tools.ant.project class depends. This file set could then be used to create jar. Now we are considering description. Type description allows for a description of the project to be specified that will be included in the output of the ant dash project help command. With regarding API, class description is used to provide the project-wide description element, that is a description that applies to a build file as a whole. If present, description element is printed out before the target descriptions. Description has no attributes, only text. There can only be one project description per project. A second description element will overwrite the first. This is in the package org.apache.tools.ant.types. Now we are considering directory-based tasks. Some tasks use directory trees for the actions they perform. For example, JavaC task, which compiles a directory tree with .java files into .class files, is one of the directory-based tasks. Because some of the tasks do so much work with the directory tree, the task itself can act as an implicit file set. Here this copies all the files in directories called images that are located in the directory tree defined by $, open curly brace, $, open curly brace, src, close curly brace, to the destination directory defined by $, open curly brace, dist, close curly brace, but excludes all *.gif files from the copy. Here deleting the original set of files, the delete task can act as an implicit file set. Now we are considering dir set. The type dir set. A dir set is a group of directories. These directories can be found in a directory tree starting in the base directory and are matched by patterns taken from a number of pattern sets and selectors. With regarding API, we can consider class dir set subclass as a hint for supporting tasks that the included directories instead of files should be used. This is in the package org.apache.tools.ant.types. Here the group of directories name classes found under the app subdirectory of $ open curly brace build.dir close curly brace, except those that have the text in their name. Now we are considering extension, type extension, utility type that represent either an available optional package formerly known as standard extension, as described in the manifest of a jar file, or the requirement for such an optional package. Here you can see the fully specified extension object. With regard to API, we can consider class extension, utility class that represent either an available optional package formerly known as standard extension as described in the manifest of a jar file or requirement for such an optional package. This is in the package org.apache.tools.and.taskdefs.optional.extension. Now we are considering extension set, type extension set, utility type that represent a set of extensions. With regarding API, we can consider class extension set. The extension set lists a set of optional packages or extensions. This is in the package org.apache.tools.and.taskdefs.optional.extension. Now we are considering file set, type file set. File sets are explicitly named list of files, whereas file sets act as filters, returning only those files that exist in the file system and that match specified patterns. File lists are useful for specifying files that may or may not exist. Multiple files are specified as a list of files relative to the specified directory with no support for wildcard expansion. File names with wildcards will be included in the list unchanged. File lists can appear inside tasks that support this feature or as standalone types. With regarding API, we can consider class file list. File list represent an explicitly named list of files. File lists are useful when you want to capture a list of files regardless of whether they currently exist. By contrast, file set operates as a filter, only returning the name of the matched file if it currently exists in the file system. This is in the package org.apache.tools.and.types. Here the files $ open curly brace doc.src close curly brace / foo.xml and $ open curly brace doc.src close curly brace / bar.xml. Note that these files may not yet actually exist. This is same as the example here. This is same as the example here and here. This is same as this is same files as example here and here. Now we are considering file set, type file set. A set of a file set is a group of files. These files can be found in a directory tree starting in a base directory and are matched by patterns taken from number of pattern set and selectors. With regarding API, we can consider class file set moved out of matching task to make it a standalone object that could be referenced by script, for example. This is in the package org.apache.tools.and.types. Here the groups all files in directory $open curly brace server.src close curly brace that are Java source files and don't have text, don't have the text test in their name. Now we are considering mapping file names. The type filter mapper. This mapper implementation applies a filter change to the source file name. With regarding API, we can consider class filter mapper. This is a file name mapper based on a filter chain. This is in the package org.apache.tools.and.types.mappers. Here you can see the change. Now we are considering filter chains and filter readers. Such custom filter readers can be easily plugged in as nested elements of filter chain by using filter reader elements. With regarding class, with regarding API, we can consider class filter chain. Filter chain may contain a chain set of filter readers. This is in the package org.apache.tools.and.types. A filter chain is a group of ordered filter readers. Users can define their own filters by just extending java.io.filterReader class. Such custom filter readers can be easily plugged in as nested elements of filter chain by using filter reader elements. And provide some built-in filter readers. Here these filter readers can also be declared by using a syntax similar to the here. However, they can be declared using some simpler syntax also. And this is equivalent to this. Now we are considering filter set. Here you are copying the version .txt file to the this directory. From the build directory, but wish to replace the token date with today's date. the type filter set. Filter sets are groups of filters. Filters can be defined as token value pairs or be read from a file. Filter sets can appear inside tasks that supports this feature, or at the same level as target, that is as children of project. With regarding API, we can consider class filter set, a set of filters to be applied to something. A filter set may have begin token and end tokens defined. This is in the package org.apache.tools.ant.types. Now we are considering a multi-root file set. Type multi-root file set. A multi-root file set is a group of files or directories. These files or directories can be found in the directory for starting with the set of base directories that are matched by patterns taken from a number of pattern sets and selectors. With regarding API, we can consider class multi-root file set, union of file dir sets that share the same patterns and selectors but have different roots. This is in the package org.apache.tools.and.types.resources. Here groups all files inside classes found under the apps directory of $open curly brace build.dir close curly brace or $open curly brace other.project.dir close curly brace, except those that have the text test in their name. This is equivalent to this example, but use nested base dir elements. The nested elements and the base dir attributes can be used at the same time and will be merged. Now we are considering pattern set. Type pattern set. Patterns can be grouped into sets and later be referenced by their ID attributes. They are defined via a pattern set element which can appear nested into a file set or a directory based task that constitutes an explicit file set. In addition, pattern set can be defined as a standalone element at the same level as target, that is as children of project as well as children of target. With regarding API, we can consider class pattern set, named collection of include exclude flags. This is in the package org.apache.tools.and.types. Here builds a set of patterns that matches all .java files that do not contain the text test in their name. This set can be referred to via pattern set ref id equal none.test.sources by task that supports this feature or by file sets. Note that the while includes and exclude attributes accept multiple elements separated by commas or spaces. The nested include and exclude element expect their name attributes to hold a single pattern. Now we are considering path-like structures. This take a general form of, for example, a class path here. This object represent a path as used by class path or path environment variable. A path might also be described as a collection of unique file system resources. The location attributes specified regarding API, we can consider class path. This object represents a path as used by class path or path environment variable. A path might also be described as a collection of unique file system resources. This is in the package org.apache.tools.and.types. Now with regarding class path here, this takes a general form of like this, and the location attribute specifies a single file or directory relative to the project's base directory or an absolute file name, while the path attributes accepts colon or semicolon separated list of locations. The path attribute is intended to be used with predefined paths. In any other case, multiple elements with location attributes should be preferred. Here path-like structure can include a reference to another path-like structure, a path being itself a resource collection via nested path elements. Now we are considering permissions. Type permissions. Permissions represent a set of security permissions granted or revoked to a specific part code excluded in the JVM where Apache Ant is running in. Actual permissions are specified via a set of nested permission items either granted or revoked. With regarding API, we can consider class permissions. This class implements a security manager meant for usage by tasks that run inside the Ant VM. And examples are the Java task that examples are the Java task and JUnit task. The basic functionality is that nothing except for a base set of permissions is allowed unless the permission is granted either explicitly or implicitly. If a permission is granted, this can be overruled by explicitly revoking the permission. It is not possible to add permissions either granted or revoked while the security manager is active after calling set security manager, but before calling restore security manager. This is in the package org.apache.tools.and.types. Here grant all permissions to the code except for those handling properties. Now we are considering property set. For example, here type property set groups a set of properties to be used by reference in a task that support this. With regarding API, we can consider class property set, a set of properties, and that is in org.apache.tools.and.types. A property set can be used as a set union of more property sets. For example, here collects all properties whose name starts with either foo or ba in the set name myset. Here the maximum at maximum one mapper can be specified. The mapper is used to change the names of the property keys. For example, here collects all properties whose name starts with foo, but changes the name to start with ba. If supplied, the nested mapper will be applied subsequent to any negation of matched properties. Now we are considering IO redirection. The redirector type provides concrete means of redirecting input and output, featuring the use of file mappers to specify source input and destination output error files. With regarding API, we can consider class redirect element representation of a redirector. This is in the package org.apache.tools.and.types. Now we are considering Regexp. Type Regexp represent a regular expression. Here defines a regular expression for later use with ID myregexp. Now we are considering a resource, a type resource, a basic resource, other resource types derived from this basic type. As such, all its attributes are available through, though in most cases irrelevant attributes will be ignored. This and all resource implementations are also usable as single element resource collectors. With regarding API, we can consider class resource, describes a file like resource, file, zip entry, etc. This is in the package org.apache.tools.and.types. Now we are considering resource collections, type resources, a generic resource collection designed for use with references. For example, if a third-party Ant task generates a resource collection of an unknown type, it can still be accessed via a resources collection. The secondary use of this collection type is as a container of other resource collections, preserving the order of nested collections as well as duplicate resources, contrast with the union. With regarding API, we can consider class resources, generic resource collection, either the class resources, generic resource collection either stores nested resource collections, making no attempt to remove duplicates or references another resource collection. This in the package org.apache.tools.and.types.resources. Now we are considering selectors. Contain selector. Here is an example of how to use the contain selector. The tag contains the contains tag in a file set limits the files defined by that file set to only those which contains the string is specified by the text attribute. With regarding API, we can consider class contains is one string part of another string. This is in the package org.apache.tools.and.taskdefs.condition. Here select all HTML files that contain the string script. In the API, the content is under Taskdefs. Now we are considering tar file set. Type tar file set. Tar file set has been a standalone type since Apache 1.7. With regarding API, we can consider class tar file set. A tar file set is a file set with extra attributes useful in the context of tar or jar tasks. A tar file set extends file sets with the ability to extract a subset of the entries of a tar file for inclusion in another tar file. It also includes the prefix attributes which is prepended to each entry in the output tar file. This is in the package org.apache.tools.and.types. Here in this example, you can see downloads the sum-archive.tar.bz2, uncompresses and extract it on the fly, copies the contents of lib directory into sum-dir and discard the rest of the archive. File timestamps will be compared between archives entries and files inside the target directory. No files get overwritten unless they are out of date. Now we are considering XML catalog. Here set up an XML catalog with a single DTD referenced locally in a user's home directory. The type XML catalog. An XML catalog is a catalog of public resources such as DTDs or entities that are referenced in XML document. Catalogs are typically used to make web references to resources point to locally cached copy of the resource. With regarding API, we can consider XML catalog. This data type provides the catalog of resource locations such as DTDs and XML entities based on the OSIS Open Catalog standard. The catalog entries are used both for entity resolution and URI resolution in accordance with the entity resolver and URI resolver interfaces as defined in the Java API for XML processing specification. This is in the package org.apache.tools.and.types. Now we are considering zip file set. Type zip file set. A zip file set is a special form of file set which can behave in two different ways. When the SRC attributes is used or a nested resource collection has been specified since Apache Ant 1.7, the zip file set is populated with zip entries found in the file SRC. When when the dir attribute is used, the zip file set is populated with the file system files found under dir. With regarding API, we can consider zip file set, zip file set. A zip file set is a file set with extra attributes useful in the context of zip jar tasks. A zip file set extends file sets with ability to extract subset of entries of a zip file for inclusion in another zip file. It also includes prefix attributes which is prepended to each entry in the output zip file. Since Ant 1.6, zip file set can be defined with an ID and referenced in the packaging tasks. This is in the package org.apache.tools.ant.types. Here zips all files in the htdocs/manual directory into the docs/user-guide directory in the archive. Adds the file changelog 27.txt in the current directory as docs/changelog.txt, and include all the HTML files in the examples.zip under docs/examples. The archive might end up containing the files here. Error example, we can consider error on missing dir attribute in type file set. Specify what happen if the base directory does not exist. If true, a build error will happen. If false, the file set will be ignored, empty. This is available since Apache Ant 1.7.1. As an example 2, we can consider this error. File set doesn't support the nested file set element. Now we are focusing on util. As an example, we can consider package org.apache.tools.ant.util. Now we are moving into other miscellaneous util components. As an example, we are considering file utils class. This class also encapsulates methods which allow files to be referred to using abstract path names which are translated to native system file paths at runtime, as well as copying files or setting their last modification time. We can consider this as an example of the usage of file utils. Here you can see a get file utils method to retrieve the file utils, which is shared by all users of this method. Here remove leading path. This method uses normalize java.lang.string under the covers and does not resolve symbolic link. Here you can see a figure out relative path of path in file if possible here. As an Example 2, we can consider class base64 converter. Base64 encoding of a string or an array of bytes based on RFC 1421. This is in the package org.apache.tools.and.util. As example 3, we can consider interface dependency analyzer. A dependency analyzer analyzes dependencies between Java classes to determine the minimal set of classes which are required by a set of root classes. Different implementation of this interface can use different strategies and libraries to determine the required set. For example, some analyzers will use class files, while others might use source files. Analyzer specific configuration is catered for through a generic configure method. This is in the package org.apache.tools.and.util.depend. Here is class facade task helper. Helper class for facade implementations encapsulates treatments of explicit implementation choices, magic properties, and implementation specific command line arguments. This is in the package org.apache.tools.and.util.facade. Class proxy diagnostist. This class exists to create a string that tells diagnostics about the current state of proxy diagnostics. It does this in its two-string operator. Java 1.5 plus is needed to compile this class. Its interface class is classic typeless Java. This is in the package org.apache.tools.and.util.java 15. Class JavaScript runner. This class is used to run scripts using JSR 223 package. This is in the package org.apache.tools.and.util.optional. Now we are focusing on Regexp interface, which represent a regular expression and the operations that can be performed on it. As an example, we can consider this one. Here the substitute method performs a substitution on the regular expression. Here the input the string to substitute on. Here you can see the argument, a string which define the substitution, and options, the list of options for the match and replace. And here it will return the result of the operation. As an example 2, we can consider package org.apache.tools.and.util.regexp. Regexp defines a regular expression for later use with id myregexp. Task regexp regexp represent a regular expression. Here use the regular expression with the id myregexp. As an exception example, we can consider build exception in substitute method in regular regexp interface. This exception occurs on error. As an error example, we can consider this one occurred in worklight application deployment Ant error situation. No supported regular expression matcher found. in java.land.class.found exception and org.apache.tools.and.util.regexp.jdk for 14 regexp. Here we can resolve this problem in two ways. One way is an Ant binary package can be installed that is independent of the Linux distribution. The other way is it's not applicable to Red Hat Enterprise Linux that comes with Ant 1.7.1, no to SUSE Linux Enterprise that comes with Ant 1.7.0. The Ant package that comes with the Linux distribution can be configured. Ensure all relevant packages are installed. Now we are focusing on other miscellaneous components. Here you can see the basic structure of an Ant build script. In the anatomy of Ant script, a typical Ant script consists of single build.xml file. The root element of the build script is the project tag. Within the project element, there are one or more targets specified. A target contains a set of tasks to be executed. The project element can specify a default target if no target is chosen during execution of the build script. As an example, we can consider listeners and loggers. A listener is alerted of following event: build started, build finished, target started, target finished, task started, task finished, message logged. These are used internally for various recording and housekeeping operations. However, new listeners may register on the command line through the -listener argument. Loggers extend the capabilities of listeners and add the following features: receives a handle to the standard output and error print streams, and therefore can log information to the console or the -log file specified file. Logging level -quiet, -verbose, -debug, aware, Emacs -mode aware. Here you can see an example of usage of logger. This simply run Ant normally, or as it is here. Here org.apache.tools.ant.default logger, the logger used to implicitly implicitly unless overridden with the -logger command line switch. Here you can see and you can run Ant normally, or like here. As example 2, we are considering getting Apache Ant, the short story. To get up and running with the binary distribution of Ant quickly, follow these steps. Step 1, make sure you have a Java environment installed. Step 2, download Ant. And step 3, uncompress the downloaded file into a directory. Step 4, set environmental variables, Java _home to your Java environment and home to your directory you uncompressed Ant to, and add $ open curly brace Ant home close curly brace /bin Unix, or in Unix, or ant home percentage /bin in Windows to your path. And step 5, optionally from the ant home directory you can optionally from the ant home directory run ant -f fetch.xml d dest equals system to get the library dependencies of most of the ant tasks that require them. If you don't do this, many of the dependent ant tasks will not be available. And step 6, optionally add any desired ant libs. Note that the links in the list above will give more details about each of the steps should you need them, or you can just continue reading the rest of the more things in the documentation. The short story for working with ant source code, not needed if you are working with the binary distribution, is 1. Get the source code. 2. Build ant. Here you can see a example build file in using Apache Ant. Notice that we are declaring properties outside any target. Since Ant 1.6, all tasks can be declared outside targets. Earlier version only allowed property, typedef and taskdef. When you do this, they are evaluated before any targets are executed. Some tasks will generate build failures if they are used outside of the targets, as they may cause infinite loops otherwise. And call, for example, we have given some targets descriptions. This causes -project help invocation option to list them as public targets with the descriptions. The other target is internal and not listed. Finally, for this target to work, the source in src subdirectory should be stored in the directory tree which matches the package names. Check Java C task for more details here. Set global properties for this build. Create the timestamp. Create the build directory structure used by compile. Compile the Java code from $ open curly brace src close curly brace into $ open curly brace build close curly brace. Create the distribution directory. Put everything in $ open curly brace build close curly brace into my project dash $ open curly brace tstamp close curly brace .jar file. Delete $ open curly brace build close curly brace and $ open curly brace dist close curly brace directory trees. Now we are considering running Apache Ant. Runs Ant using the built XML file in the current directory, the default target. here the class main command line entry point into Ant. This class is entered via the canonical public static void main entry point and reads the command line arguments. It then assembles and executes an Ant project. This in the package org.apache.tools.ant. Now we are considering running Ant via Java in running Apache Ant. If you have installed Ant in the do-it-yourself way, Ant can be started from one of the two entry points. The first method runs Ant's traditional entry point. The second method uses Ant launcher introduced in Ant 1.6. The former method does not support -lib option, and all required classes are loaded from the class path. You must ensure that all required jars are available. At the minimum, the class path should include ant.jar and ant-launcher.jar, jars/classes for your XML parser. The JDKs required jar/zip files. The latter method supports -lib, -no userlib, -no class path options, and will load jars from specified Ant home. You should start the latter with the most minimal class path possible. Generally, just the ant-launcher.jar. Now we are considering targets in concepts. A target is a container of tasks and data types that cooperate to reach a desired state during the build process. With regarding API, we can consider class target, class to implement the target object with required parameters. This is in the package org.apache.tools.ant. Targets can depend on other targets, and Apache Ant ensures that these other targets have been executed before the current target. For example, you might have a target for compiling and a target for creating a distributable. You can only build the distributable when you have compiled first, so the distribute target depends on the compiled target. Any entries to execute the targets in the depends attribute in the order they appear from left to right. Keep in mind that it is possible that the target can get executed earlier when an earlier target depends on it. Suppose we want to execute target D from its depends attributes. You might think that the first target C, then B, and then A is executed. Wrong. It's wrong. C depends on B, and B depends on A. So first A is executed, then B, then C, then D. In a chain of dependencies stretching back from a given target such as D above, each target gets executed only once. Even when more than one target depends on it, thus executing D target will first result in C being called, which in turn will first called B, which in turn first call A. After A, then B, then C have executed. Execution returns the dependency list of D, which will not call B and A since they are already called in the process. In the process of dependency resolution for C and B respectively as dependencies of D, had no such dependencies been discovered in processing C and B and A, would have been executed after C is processing this dependency list. Now we are considering extension points. For example, your important build file may need to compile code. It might look like this. Extension points are similar to targets in that they have name and depends list and can be executed from the command line. Just like targets, they represent a state during the build process. With regarding API, we can consider class extension point. An extension point build files can provide as a place where other build files can add new dependencies. This is in the package org.apache.tools.ant. Unlike targets, they don't these extension points they don't need any task. Their main purpose is to collect targets that contribute to the desired state of their depend list. Targets can add themselves to an extension points extension points depend list via their extension of attributes. The targets that add themselves will be added after the targets of the explicit depends attribute of the extension point. If the multiple targets and themselves, their relative order is not defined. The main purpose of an extension point is to act as an extension point for built files designed to be imported. In the imported file, the extension point define a state that must be reached, and targets from other built file can join depends list. Of said extension point in order to contribute to that state. For example, your imported build file may need to compile code. It might look like here. Call graph, create directory layout here, and empty slot, then compile. Now we are for considering built-in properties in properties. Base dir, the absolute path of the project's base dir as set with the base dir attribute of project. With regarding API, we can consider class directory scanner. protected file base dir, the base directory to be scanned. This is in the package org.apache.tools.ant. Now we are considering property helpers. Here's the logic that replaces the $ open curly brace toString colon sum dash id with the stringified representation of the object with some ID inside the current build is contained in a property evaluator similar to the following code. The class property helper deals with properties, substitution, dynamic properties, etc. This is in the package org.apache.tools.ant. Now we are considering ant.build.clone VM. The value of the ant.build.clone VM system property controls how Ant instruments forked JVMs. The Java and JUnit tasks support clone VM attributes to control JVMs on a task by task basis, while the system property applies to all forked JVMs. Now we are considering build.sys class path. The value of the build.sys class path property control how the system class path, that is class path in effect when Apache Ant is run, affect the behavior of class paths in Ant. The default behavior varies from task to task. Now we are considering Ant properties control in Javac. Ant.build.javac.source provides a default value for Javac's and Javadocs source attributes. Common attributes of all tasks. All tasks share the following attributes: ID, unique identifier for this task instance, can be used to reference this task in steps in scripts. Task name, a different name for this task instance will show up in the logging output. Description, room for your comments. Now we are considering if and unless. Since Ant 1.9.1, it is possible to add if and unless attributes on all tasks that and nested elements using special namespaces. In order to use this feature, you need to add the following namespace declarations. and if and unless namespace support the following three conditions: true if the value of the attributes evaluates to true, blank if the value of the attributes is null or empty, set true if the specified property is set, now we are considering assigning namespaces in XML namespace support. Thus, instead of adding a prefix attribute, the typedef and task get the URI attributes which store the URI of the XML namespace with which the type should be associated. The class typedef adds a data type definition with regard to API. Adds a data type definition to the current project. Two attributes are needed: the name and name that identify this data type uniquely, and the full name of the class, including the packages that implements this type. This is in the package org.apache.tools.and.taskdefs. Adding a prefix attribute to typedef might have been enough, but XML already has a well-known method for namespacing. Thus, instead of adding prefix attribute, the typedef and taskdef task get a URI attribute which stores the URI of the XML namespace with which the type should be associated. Now we are focusing on antlib. A group of tasks and types may be defined together in an antlib file. For example, the file sample.xml contains the following here. Antlib. An antlib file is an XML file with the root element of antlib. Antlib's elements are Apache Ant definition tasks like Taskdef or any Ant task that extends org.apache.tools.and.taskdef.antlib definition. The current set of declarations bundled with Ant that do this are typedef, taskdef, macrodef, presetdef, scriptdef. A group of tasks and types may be defined together in antlib file. For example, sample.xml contains the following. It defines two types or tasks. If an script mapper, this antlib file may be used in a built script as follows here. The other attributes of type def may be used as well. For example, assuming that sample.xml is in a jar file, sample.jar, also containing the classes, the following build fragment will define the if an script path mapper tasks / types and place them in the namespace URI samples : /acme.org. The definitions may then be used as follows. Now we are considering a type def in antlib. The following fragment define a type called URL set. Type def adds a task or a data type definition to the current project such that this new type or task can be used in a current project. With regarding API, we can consider class antlib. With regarding API, we can consider class type def adds a data type definition to the current project. Two attributes are needed: the name that identify this data type uniquely and the full name of the class, including the packages that implement this type. This is in the package org.apache.tools.ant.taskdefs. The following fragment define a type called URL set. The data type is now available to Ant. This class, the class com.mydomain.url set implements this type. Now we are considering macro def. The following example defined a task called testing and runs it. Macro def, this defines a new tasks using a sequential nested task as a template. Nested elements attribute and element are used to specify attributes and elements of the new tasks. This gets substituted into a sequential task when the new task is run. With regarding API, we can consider class macrodef. Describes class macrodef here. This is in the package org.apache.tools.ant.taskdefs. Now we are considering preset def. The following fragment defines Java-C task with the debug, deprecation, src directory, source directory, and destination dir attributes set. It also has src element to source files from the generated directory. Preset def. The preset definition generates a new definition based on a current definition with some attributes or elements preset. With regarding API, we can consider class preset def. The preset definition task generates a new definition based on the current definition with some attributes or element preset. This is the package org.apache.tools.and.taskdefs. This can be used as a normal Java-C task, for example, here. Now we are considering script def. When executed, the resulting task logs the value of attributes and the base dir of the first file set. Script def can be used to define an Apache Ant task using a scripting language. Ant scripting languages supported by Apache BSF and JSR 223 may be used to define the script. Script def provides a mechanism to encapsulate control logic from a build within an Ant task, minimizing the need for providing control style task in Ant itself. Complex logic can be made available while retaining the simple structure of an Ant build file. Script def is also useful for prototyping new custom tasks. Certainly, as the complexity of the script increases, it would be better to migrate the task definition into a Java-based custom tasks. With regarding API, we can consider script def. The class script def defines a task using a script. This is the package org.apache.tools.and.taskdefs.optional.script. The following definition create a task which supports an attribute called ATTR1 and nested elements, one being file set and the other a path. When executed, resulting task logs the value of the attribute and the base dir of the first file set. Now we are considering custom components. For example, custom condition that returns true if a string is all upper case, could be written as follows. The interface for conditions to use inside condition tasks. This is in the package org.apache.tools.and.taskdefs.condition. Custom conditions are data types that implements org.apache.tools.and.taskdefs.condition. For example, a custom condition that returns true if a string is all uppercase could be written as follows here, and adding this is the setter for the value attributes. This method evaluates the condition. Adding the condition to the system is achieved as follows. This condition can now be used wherever a core ant condition is used. Now we are considering log4j listener. In listeners and loggers, message events are logged according to their logging level, mapping directly to the corresponding log4j level. The class log4j listener is deprecated. Apache log4j is not developed anymore. Last release is 1.2.17 from 26 May to 2012 and contains vulnerability issues. Use the standard listener or your own custom listener instead. This listener which sends us events to log4j logging system. This is in the package org.apache.tools.and.listener. This passes the build event to log4j using full class names of the generator of each build events as a category. Build started, build finish, org.apache.tools.and.project, get started, target finished, org.apache.tools.and.target, task started, task finished, a fully qualified class name of a task. Here you can see build started and build finished, org.apache.tools.and.project, target started and target finished. In org.apache.tools.and.target, tasks a fully qualified class name of a task, message log, a class name of one of the above, or so if a task logs a message, its class name is the category used, and so on. All start events are logged as info. Finish events are either logged as info or error, depending on whether the build failed during that stage. Message events are logged according to their ant log level, mapping directly to a corresponding log4j level. To use log4j, you will need a log4j jar file and a log4j.properties configuration file. Both should be placed somewhere in your ant class path. If the log4j properties is in your project root folder, you can add this with the -lib option. If, for example, you want to capture the same information output to the console by default logger and send it to a file named build.log, you could see the following configuration here. Now we are considering default logger. In loggers and listeners, simply run ant normally. The class default logger writes built events to a print stream. Currently, it only writes which targets are being executed and any messages that get logged. This is in the package org.apache.tools.ant. Now we are considering installation instructions from the readme txt in Antwork plugin for Regexp Java text editor in IDE integration. You have to enable Regexp console to see the Apache Ant output, menu, edit options, then general panel, because Ant messages are directed to the Regexp console. You can configure the Ant call in a Regexp menu, edit options, then plugins options, then Antwork plugin panel. Here you can set Ant home directory and the path to your build file. You can start Antwork in the menu, plugins, then Ant, then work. Now in the appearing dialog box, you can enter the target which you want to compile. If a JavaC error occurs in the Ant run, an error list opens within Regexp. With the double click on the error message, you jump to the error in the specified Java source file. Now we are considering Ant API. Here we can consider as an example package org.apache.tools.ant. This is the end of my presentation. Thank you very much for watching.